name's Josip Injić, or Josip Injić. I also go by the Croatian sensation. Those that don't know me, I am new to Capital One. I've been here about, I want to say about a month. They did not haze me to do this presentation. They actually volunteered, and I've done it before at Cocoa Heads, and I hope that we can continue going and doing it here at DC iOS, in the future. So if you do have anything to talk about, definitely sign up for the link. So today I want to talk about views in iOS, and more specifically, how to lay out these views. It's a holy war that's been going on for years. Programmatic versus storyboards versus nibs. Like, what's the best way to do it? What are the pros and cons of each? And we'll kind of dive into a little bit of everything there today. So we'll talk about like the old way of doing things, and then kind of the new world of where we're going to with layouts. So take a ride with me on the BFR, and we had to make something cheesy in there. So a long time ago, I started working at BMW. That was my first job, doing iOS development, and I quickly learned from these guys. You know, I worked with tutorials before, and I've done everything with storyboards, and that's how I picked up iOS. This is initially back with just Objective-C. So I joined this team, and the first thing they tell me is, delete all your storyboards. Like, they're terrible, do not use them, they have all these reasons. And I'm like, well, this is how I learned to develop like views. Like, how else are you gonna do it? Well, programmatically. Well, why would we want to do it programmatically? And actually, 1 second, I'm sorry, it is not sharing my, I need to dual screen. Better, you guys can still see? Cool. So why would we want to do it programmatically? Sorry about that. So there's a few reasons, right? It provides more control on our code. There's more reusability there when you do it programmatically. You have less merge conflicts when you do it programmatically. And you'll have less clutter and navigation when you do it programmatically. So what do I mean by these things? So if we look at control, I can define all my colors, let's say, in a global struct, that tomorrow, if I look at my buttons and my title label, if my designer said, hey, we're doing a Halloween theme next month, could you change all the colors to this Halloween colors that I have set up? Well, sure, that's easy. I can go and change that in my struct, and then I don't have to go through every single view in my storyboard and change these colors individually, right? And we can do the same thing with fonts, font sizes, padding, all that. So a lot of benefit there for control on your code. But how would we do it with constraints? Well, we have the visual formatting language, or VFL, that we can do that with. Another one is layout anchors, something that's a little bit newer and easier to read as a developer. But also for dynamic layouts, we have the ability to activate and deactivate these individual constraints that we create to fit with our business logic. So if whatever logic you're following needs one view versus another to change it a little bit, we can mess with our constraints to do that on the fly as the view loads. So let's talk a little bit about reusability. So with reusability, I mean, when you're looking to recreate a view in a storyboard, a lot of times we have the issue of trying to copy and paste these views within the storyboards, and you get some weird issues with the IB outlets and identifiers, and storyboards have gotten better about this, but in the beginning they weren't there. With programmatic like views, the easiest way to, let's say, copy this button that I have here is copy and paste it, right? You change a few, you change the title, you can change the colors, and you can copy and paste those constraints over, and you have the same button somewhere else with little or no time. You're pushing, copy and paste, and you're done. What about merge conflicts? So when I say when you do it programmatically, you have less merge conflicts. So you won't run into this. We've all run into it as developers, and it's not fun, right? Storyboards, when you have a large storyboard files and multiple developers are changing the same view, we end up creating these huge merge conflicts that are just XML. And at BMW, the way, or not BMW, but before, when I was in school learning how to do iOS using storyboards, when two of us would get in a merge conflict, if I was the one that's merging, I would merge mine in and be like, hey, Mike, there's an issue with your PR. It's conflicting. So can you take a look and resolve that? And he's like, I don't know what I'm looking at. I'm like, yeah. He's like, well, I finished mine first. Why is yours going in? I'm like, I don't know. So yeah. So less merge conflicts we do programmatically. When you get code conflicts programmatically, it's something that we can read, right? It's not XML that's created, for us by Xcode. So we'll get into a little bit about that too. And then how about clutter and navigation? So imagine your first iOS app or your first gig doing iOS, right? You probably remember there was a file called main.storyboard, and you open up this file and there's this huge storyboard in there, right? It's all these different scenes and it looked a little bit like this. And now I know what you guys are thinking. That is not a storyboard file, right? I'd say look closer, right? It is. You would have so many storyboards on there that there's arrows and stuff pointing everywhere. It was legitimately just spaghetti everywhere. A bunch of segues and stuff lined up. So the file would even, the more scenes you had in there, it would be slower to navigate that storyboard file. So at BMW, how did we do this? Well, the first thing we did was delete our storyboard. So you open up a new project as a template, and because Apple doesn't make this easy for you, you need to start a new project with a storyboard template inside. So you'll have the main.storyboard, and you'll go in there, you'll push delete, and you'll move it to your trash, right? Now, if you try to run, that will crash your app. So what you need to do is go into your General tab under your project, and you'll see this little main interface section. You'll want to go ahead and erase the reference to main. Now, depending on what Xcode you're using, it could still reference your storyboard, your main.storyboard in the plist. Some versions of Xcode do, some don't. If you're using Xcode 11, it does. So you still have to go into your plist and remove that one more spot so you don't have to worry about that reference. But you're still not done. So if you're using something below Xcode 11, you'll have to go into your app delegate and you'll create this window. And you'll set the Windows frame to the bounds of the screen. So if you think of a window like on your computer screen when you open up, let's say Safari or something, that's a window. Your phone has it too, but you only get one, right? So you'll create that window and you're setting your initial view controller to the root view controller. Now here I'm just using a generic view controller that's provided to me from the template, but that would be whatever your initial view controller is. And then you will call make key and visible. Now, you don't necessarily need to know what exactly that does, but just know that you need to use it to make this work. If you're using iOS or Xcode 11, there's a new delegate called scenedelegate.swift. And this is kind of where your new window would have to be set. So if you are using Xcode 11, same idea, but you're checking here for a window scene first before you set your window. And then you add the window scene, and then just as before, add the root view controller, and then make key invisible. So when you finally run your app, it's going to look like this. And it looks like your phone's not on. So we can go to the initial view controller that we created, and we can set the background color to white. And now you're in exactly the same spot you would have been had you just used the storyboard. But we have the ability to do everything programmatically now. There's a lot of steps there. If you guys didn't get a chance to follow them all along, take a look at my new blog. There's a specific one on deleting all your storyboards at creationsensationblogs.com. It's a mouthful, but we'll post that on the link later. And there'll also be a few more blogs coming out that are related to this topic. So if you guys even want to go hop on there and subscribe, there'll be additional information related to this talk. So continuing on. So how do we go ahead and create these views within, now that we don't have IB outlets, right, that we typically have with storyboards? Well, we're creating them programmatically as well. So here you can see I'm creating a button and a title label, and they're both done with the lazy var. And the reason I want to do that is because my views are most likely going to be dynamic, right? So sometimes a button may be included, it might not. Sometimes the title label might be there, it might not. But in the case that it's not, I want to load it to memory. So a lazy var allows us to do that. We're only going to load this and use it and set it to memory once it's actually called upon. And then how do we set constraints on these new views? Well, we can use something like the visual formatting language. So the visual formatting language looks scary at first, but if you look a little bit closer, this is kind of the main thing we want to look at, and I can enlarge that a little bit for you. So this is kind of intimidating string here that we have. Like, what is it doing? Well, here in the beginning, you'll see this H. So this is defining the string as a horizontal constraint that we're creating. If it was a V, then there'd be a vertical constraint. If you don't specify anything, then you're just setting a horizontal constraint by default. And then if we look at the next part of this string, we have these two pipes. This is our superview connection. We're defining the actual superview of our screen. Now, if these two views are subviews to a, like say, a parent view, then this would actually be describing that parent view, right? But in this case, I'm doing it directly onto my superview, and that's exactly what I'm specifying there. Moving on, you'll see there's some numbers in here, some dashes. So if you just see a regular dash, that's going to be standard spacing, standard padding from here. In this case, it's my app name label to my leading constraint, or my leading pat margin. And so what is standard spacing? Standard spacing is usually around 8 points, but the value can change if it's spacing through the superview. And then you'll see that there's non-standard spacing. So that's something that I actually go and define as I want, 15 points of padding here. But 15 points of padding, this is something that I choose to define. So you can set whatever number you'd like there. But if you look at the view, so these bars here, they represent these margins that I've set on here. So the red being the standard padding, and the gray being the non-standard 15 points, right? And you'll see that the non-standard padding is kissing the skip button, versus the red and gray does not kiss the name button. Now, why is that? Well, if we look at our views that we have in here, you'll see the 30 that's in there represents the width of the skip button that we've set. And that name label does not have anything set on there. So what's happening is that the skip button has a defined width, versus the app name label is expanding, right? But we can't really tell, because although the view is expanding and the name label is centered, we can't see it expand. So if we actually set a background color to it, you'll actually see that it kisses the sides as well. And this is an important thing to remember when we look further on down into something like Swift UI. So how do I get these views in here, right? Because they're just strings. Like how does the visual formatting language recognize that this is actually my views? Well, we pass in a views dictionary. So this is the key for that dictionary, and then the actual values would be whatever you're passing in from before. So in my case, it would be that title button and the button, and then the title label that I passed in. But we can mess with these numbers too, right? Because we don't want any magic numbers in our code. But we also want to be able to change this maybe down the road if we choose to. So we can add something like metrics to that. And metrics are important. This can be somewhere that you set globally, but you'll just pass into this method. So that means that the visual formatting language now can accept not only views, but also like floats that we can use as padding. So here I have a P defined as padding for 15 and W for width on 30. And again, if my siren told me tomorrow I need to adjust these, there's no dabbling around. I can have a center place for all this padding in one spot that can go adjust. And we can just toss those right into our visual formatting string. But we can get even more defined with visual formatting language. So a little bit more complicated view. So from what we just learned, here I have a horizontal constraint where I have an icon with an equal width to my icon date. Next to that, I have 20 points of padding, then an icon label with a width of 120 at a 125 constraint priority. So if you look to the right of that, there's 20 padding with 750 constraint priority, meaning that padding has a stronger constraint than the width of the icon label. And then the icon date, you can use something like a greater than or less than, in this case it's greater than 50, to have that fluctuate, just as you would in storyboards. And your icon would, of course, adjust to that as well, because its width is equal to the icon date. And you would do the same thing individually for the vertical constraints for each of these views. Now, these are kind of the old way of doing constraints, right? So you have the visual formatting language, you have NS layout constraints, kind of what we used in the past, People still kind of use visual formatting language, a little bit less on the endless layout constraints. I don't think I ever saw that in production code. But I mean, it's still like a usable thing. And then even before this, we've had something like frame math, where you're actually like using pixels to determine your area on the XY axis of your screen, which we don't really do anymore because Apple wants us to using points. We have different screen sizes, different screen densities. So that's kind of out now. But then came something awesome, iOS 9. And about the same time, I started working at the Washington Post. And iOS 9 brought us a lot of things. And it was a lot of useful things, but the way the Washington Post worked was a little bit different than BMW. Washington Post really liked storyboards. And I came in brainwashed, I hate storyboards. Like, so my first pull request was obviously all programmatic code. And I got rejected by every single developer on the team. And I was like, why are you guys so against programmatic views? Well, the answer to me was every line of code that you write is another potential crash that you write, right? So if the more we can do in storyboards, the better. And that was the ideology there. So with iOS 9, we had some new things that got added on. One of those being anchor constraints. It was a new, cleaner way to create constraints. Developers can easily read it rather than looking at a visual formatting language and trying to decipher what views are being passed into the dictionary. This was just very easily readable by a human. The second was a storyboard reference. These are big for those large spaghetti storyboards that we talked about before. This will help simplify that for us now in the future. And last but not least, stack views. Stack views are awesome. Stack views allowed us to stack views vertically, horizontally, without adding any constraints to them inside. So we only have to worry about the constraints on the outside, which most typically would be to the bounds of the screen. But of course, we're never typical, right? We always try to do some fun stuff with them. So they definitely helped us, get away from programmatic code. But let's take a look at anchor constraints and what they look like. So similar to the visual formatting language, these are done programmatically as well, and we can set whether these constraints are active or not. So just looking at the center X anchor, it's super easy to read. So I have a new view that I've created, and I have my view that's like my super view, for instance. So here I'm saying my new view center X anchor, its constraint is going to be equal to the super view's center X anchor, and this constraint will be active. And just like visual formatting language, if I need to turn on and off constraints on the fly, depending on my business logic, I can still do that here programmatically. Same thing here with my width and height anchor. I'm saying my new view's width anchor's constraint's going to be equal to 50. Again, this can be a global variable if it needs to be, and I can set these on and off depending on what my business logic is. So one thing that I missed on here that if you guys done programmatic, you might have already caught. And if not, it's all right, because I feel like anytime we do programmatic lay of views and lay them out, this is always missed. But translating our outer resizing mask into constraints needs to be set to false. Otherwise, we're going to get some weird issues. This is typically set to true by default for us. When it's set to true, the view fully specifies the view size and position, and we can't add any outer layout ourselves when it's set to true. Interface Builder sets this to false for us, but we have to do it manually if we're going to be doing programmatic code. And I'll do that just by sticking it right there in my lazy var. That way I'm set and ready to go. Now, we've all run into this where whether we're doing code programmatically or in storyboards and nibs, we end up running into some endless layout constraint error, right? It shows up in our log. Sometimes we ignore it because the view looks like it's supposed to. But maybe your senior dev notices it and he rejects your PR because of an ugly error like this. So more advanced developers, they've kind of ran into endless layout issues for so long that they've kind of started to get a feel for like, what is this error actually telling me, right? And then going to my screen and resolving it. For those of you that maybe are still new or trying to figure it out, awesome recommendation I can make for a website is WTF auto layout. Why the failure? So you can add in your log that you're having an error with, and then you'll get some actual helpful resources back if you can't understand it from like the beginning. So yeah, great website to check out. So let's look at storyboard references. So we talked about how storyboard references help alleviate the spaghetti board problem that we talked about before. So a storyboard that has a bunch of scenes might look something like this. This one actually looks kind of nice and organized compared to some of the other ones I've seen. They've slowly had nightmares about them since I've been doing iOS. But with storyboard references, we help eliminate merge conflicts here. And this is XML that's generated by Xcode when you create your storyboards. Code conflicts here are hard to resolve because I don't know about you guys, but I can't read XML that well. I can pick stuff here and there, but I'm not that good at resolving conflicts there. So the solution to that is to use a storyboard reference. So we want to use one scene per storyboard. And rather than using the segue to the next view, we're just segueing to that storyboard reference. That way, each storyboard file has one scene, and I can have now multiple developers working on multiple scenes without running into conflicts with each other. And this was a huge step in iOS 9 when that was released. Then we have stack views. Very easy way, like we would have to add a bunch of constraints before to create equal padding between these three yellow views on the screen. But now stack views make it easy. You just toss them in, you can set equal spacing on there, and all you're worrying about is setting the outer constraints on that view. And not only can we do a stack view like that, we can do stack views within stack views. And like I said, no auto layout is going to be needed for anything inside of the stack view, besides like spacing and if you wanted like to set priority on there or specific widths. But for the most part, they're plug and play for the most part. Moving on, so that's like our storyboards. So storyboards made it easy for us, where we can, easily drag labels onto the screen. We can see what those labels look like, and when we need to manipulate data or anything, like storyboards are definitely a way to go. But then we also have these nibs or XIB files, we call them. So what are they for? I find them really useful when I need to use the same view, like a static view, over and over again. So for example, I have a table view that relies on an API. And let's say the API is down, or I don't have cellular signal, and now I can't pull that data down, and I have an empty table view. Well, rather than showing that, I can just load this nib and stick it in there and reuse that for any table view I have, right? So that makes them very, very easy to use, and they're a great tool for your toolbox. But interface builder and storyboards helped us a lot to get up to speed developing apps, making it easy to lay out adaptive user interfaces and setting up segues for navigation. But many developers prefer to create their production views in code, probably because it's more efficient to copy or edit UI when it's written on code, right? But mostly because interface builders and storyboards have built-in gotchas. You edit the name of an IB outlet or an IB action, or delete it from your code, and now your app's crashing because that IB outlet's no longer connected. Or maybe you have some ID that you're referencing, let's say for your table view, and it's referencing your storyboard, but you didn't set it in your table view. Well, now you have a crash. It's a very imperative way of looking at programming, right? We have to define every single thing we do. The layouts, how they're going to be set, whether you set the phone horizontally or vertically. So what came along to fix all that? Well, our new planet, or our new world, I should say, Swift UI, right? And it's a little barren. There's some things that are missing from it. There's some weird error messages that we run upon that I don't fully understand. There's some weird gotchas that we're still, they're still trying to figure out. But most importantly, it doesn't support anything under iOS 13 right now. So if it is something you're trying to use, I'd say that you're either putting a if available on there to check for iOS 13, or you're holding off till these bugs are resolved, and we can finally start using it. But I mentioned before, everything we used was imperative, but everything here is declarative. What do I mean by that? So imperative is, let's say I want to draw a landscape, right? So I call Bob Ross, and I listen to every single step he tells me, every stroke to create this landscape, right? That's imperative programming. I have to follow along perfectly and get everything right. Well, declarative is when I go up to an expert and say, hey, can you draw me a painting of some landscape, maybe a mountain and a lake? Well, they know exactly like what I'm talking about. Like they can just do it, and they're going to do way better than me. The best artwork that I've done was a stick figure back in 3rd grade. I think my mom still has it in the fridge. Um, so that's definitely the way to go. But looking at Swift UI, we have this new view protocol. And this is kind of how we're going to start defining what our view is going to look like in the future. Now, this is the end of my slideshow, but I like to go into Xcode and start a new project with you guys and play around with Swift UI. So I apologize. I hope the gods are with me today for a live demo. Yeah, yes. So let's see. We'll call this DCiOS. So the first things first, we need to set our user interface. No. Look, they're already against me. Here. Thank you. iOS. Good. Watch what you say. All right. So we're selecting our user interface. That's where we left off last time. So we have the options here between Swift UI and Storyboards. So we want to do the new way. So we're going to go with Swift UI. Click next. I'll just save this to my desktop so it's easier to find, delete later. All right, so we have our little view. We got our content view, which adheres to that, that view protocol that we talked about before. And over here, we can run our canvas. And if you guys didn't see how to get to that, it's this little button up here, and you just click on canvas. So this will be the new way of doing things, right? We talked about it with storyboards. If we change something to a storyboard, such as like an IB outlet that we disconnect or an identifier that we change, we'll have a crash if we don't make that same change in code, right? So the beauty of this is I can go into, let's say, this label that I have now, and I can set it to large, and you'll see that my code is changing too. Let me make this larger for you guys in the back and set it to presentation. Well, yeah, I forgot that's a way too. No, it is not like that. that is typically the way I do it, but for the sake of working like I remember it does. You guys want dark mode? Yeah, everyone wants dark mode. Dark mode presentation. Better? Cool. All right. Hide that. We don't need that right now. All right, so we will resume this. So we saw that. No, we didn't. Where'd it go? So we have our hello world, and we want to change the font to a larger font. So not only does that change in our canvas, it also adds a modifier to our text there. We can add some, what are you doing? All right, they don't like me. God, they don't like me. We can add different weights to that, such as a thin, different colors. We'll just keep it a black for now. But we can also go play with that directly in code. So for example, if I want to go and add padding here, I can do that. And that's going to add a little padding around my view. I can go and add background color to this text field. How about blue? Or that's going to be hard to see. How about yellow? Cool. So now we have a background color. But the way you add in modifiers are important, right? So if I were to, let's say, add the background before the padding, so now you'll see that the padding still goes out and around it, but the background color is only set on the text itself. So interesting thing about modifiers is that each and every single one of these modifiers is its own view, which you would think, maybe that's the wrong way of doing things because that's kind of recursive, right? When you have a view within a view. But Xcode does like a really good job of doing this for us. So it actually brings everything in together as one kind of binary or one like flat map if you want to talk about it. And it's very efficient. So we don't have to worry about like how many views do we have within a view when we talk about these modifiers. It's well handled. Let's see. So there we have our text. Now we have like, we talked about stacks before, and we still have stacks here. So we can do like a vertical stack. Side of that, we can take this text modifier or this text view that we have. stick a vertical stack in there, right? So looks the same. If I do it twice, now we have this easily stackable view, right? And then within this, we can continue messing with it. We can say, how about I put two of these views next to each other, right? And I can do something like a horizontal stack. And then take this code. And then if I wanted to stack them vertically, right, I just stick another one in this vertical stack. And it's really easy to start generating and creating these views, right? So definitely this makes it a little bit simpler. It links everything up together. And it helps it work, a lot easier or a lot better for us. Now, one other thing that we have is we have the library, the view library. So this gives us the actual views that we can add on here, such as buttons, date pickers, everything you're used to in your storyboards. And the way I got to this was Command-Shift-L to get to the library. We can do searches for views here, whether we want to form our list. But the other neat thing is too is like for maybe someone that's new to iOS development who likes storyboards because they provide you GUIs already, and you can easily go through those individual buttons and GUIs and know what attributes you can add to, let's say, your text or your background color. We can do something similar here too, where we can say, open up this library and let's look at the modifier library. And we have a bunch of options on here. Once I erase that search, a bunch of options on here that I can use for any view. So for example, if I want to do something like adding a blur to Hello World, I can easily do that. And that used to be really hard to do back in the day, right? So now it's as simple as just setting it. And so we have a bunch of modifiers that we can do, create views really easily. So another thing that I wanted to show you is about a table view. Like if we want to create a list in here. So copy paste it. Cool. So what am I doing here? So I've added a list, which is being laid out for me on its own. And then inside, I'm creating a horizontal stack with a text view that takes a value of name from this data set that I have up here. And the last name is just hard-coded to whatever the last name may be. So when we look at this, the list view, it takes in this new property here, or not property, but a protocol called identifiable, where it has to take an int and a name. So I don't know if you guys got to listen to the talk on diffable data source. If you haven't, take a look, but it'll create an identifier for you and associate that with your list view for your data source. That way you can easily do searches and queries on there, and all the animations, everything will be done for you. So identifiable already does that for us in the list, and that's all I'm setting up here for my model called info, where I set a name to that. And it's pretty straightforward. There's not a lot of code, but I have a usable table view right out of the box. It's really simple, easy to do. But there's some gimmicks with this as well. So if I go back to these crazy stacks that I had, let's just bring it back down to the base. So bring it back down to the base. We have enough of these. All right, so let's say I just want a text label. Hello. So really funny thing that I found. We have one, it works great. Yeah, one, it's good. I should stick this in a horizontal, or let's say vertical stack. Oh, one works great. Two, also fine. Three, we can do. 4, 5, 6, 7, 8, 10. Still works good. 11. We're getting an issue. Why? Ambiguous reference to member build block. So what happened here is that there was a developer at Apple that said, why do you need more than 10 views in your stack or in your view object? And basically, either that or it was just too lazy to do it, but that's the limit right now is 10. So you go over that, you're going to get this weird error, and that's what it is. I was trying to push to its limit, so that's what I ended up getting at it. So yeah, there's definitely gimmicks like that you're gonna come upon, and if you look at some of the initial talks that they had during WWDC, a lot of them, like a lot of stuff they talked about has changed throughout the betas, and like if you already run their demo apps, they're already breaking with the latest Xcode. So SwiftUI is still growing a lot, and like I don't think we're fully there to use it, but it's hopeful, right? It's kind of like Mars. Like it looks like a great idea to get there. It's gonna be a new world. We're gonna live on it, whatever. But we're not there. We're not there yet, 100%. I think this would be cool to play with and mess with, but I don't know if I'd put this in production code yet, especially with so many changes coming around. But you can see why this might help end that holy war that we talked about in the beginning, right? Because now we can modify code in a storyboard that's visible and like easily readable by a developer in Xcode, and vice versa. I can modify things here that a new developer can visualize in a storyboard. So, I mean, we talked about doing it with visual formatting language. We talked about layout anchors. We talked about doing it with storyboards and with nibs. And honestly, I think for right now, I'll probably stick between a mix of storyboards and nibs, or sorry, storyboards and programmatic code, because it allows you to still, have that control that you can have with programmatic development, but it allows you to have new developers come in and still understand what you're doing, right? Because that's how they learned to do iOS, was probably with storyboards, and that's probably kind of the easiest route. But that's all I had to show for you guys today. So luckily, thank you guys again for the new HDMI core, Tommy, where you're at. Big round of applause for him. Where he's at back there. The gods were happy to me the second half. So is there any questions that anyone has, or maybe even open up discussion? I know this is like I said, it was a holy war topic in the beginning, and maybe get some views on SwiftUI if more people have played around with it so far.
Also, there's these fancy little microphones in front of you with a button that says mic. I don't know if it works for all of them, but might be worth trying it.
No. We do use Swift. We do use Swift. We have some Objective-C files that we're converting over. What I'm saying is we don't yet use Swift UI, and so this is a brand new way of creating layouts. And well, no. So this last thing I was showing. Sorry, maybe it wasn't clear. So this last thing here, Swift UI is this declarative way of creating views, right? Is when you're creating stacks here in code and can add labels and whatnot, but you can still manipulate it here and on your canvas. It's a little bit of both. Yeah, it's a programmatic way of doing views, but you still have the visual there as you're writing it. And I should start off by saying the reason I couldn't switch computers during my debacle here was because SwiftUI does require Xcode 11 and Catalina. You can still create SwiftUI views with just Xcode 11, but you can't use this canvas that's failing to load for me. Oh, there's still 11. There you go. Unless you have Catalina as well, so that won't actually work for you without that. But we do definitely use Swift here. We're a big Swift house, at least as far as I see. I'm only been here a month, like I said, and I've worked with a lot of Swift so far here. So they just announced it the last WWDC. Yeah, so this is what, June or May? When was it? June, I think. Yeah. So since June, so it's still pretty new, and that's what I'm saying. It's still a little bit iffy, and it doesn't work with anything under iOS 13. So if you are supporting old apps, this isn't the way to go unless you want to check for availability each time you launch a view. I haven't done it with Catalyst yet, but I know it's supposed to help make it definitely easier, since you're basically showing the same objects and everything on the screen. But no, I didn't get to play with that individually yet, but definitely something I want to mess with soon. For Watch, I have not, but Catalyst is bringing it to the Mac, right? Right. Yeah, I mean, from what I saw, it looks like you can just bring it over, but I haven't got to play with with Mac, yeah, I've been specifically just doing the iOS side of it. I'm back. If I can only pick one tomorrow, well, Stuart here would be very upset with me. Um, but yeah, tomorrow, so to still be able to hold on to all of our um, different changes and stuff that we do within our app, I'd say programmatic then is the way to go. We still want to have the control, easily be able to change things. So yeah, the advanced way is the programmatic way. Um, the storyboards just allow for like newer developers coming on board to like easily pick that out. But I think for more senior level developers, we already know the attributes and everything on there well enough that we don't need a GUI to tell us, what we need, just what options we have to set there, right? We're good enough that we can look at the documentation of, let's say, a view or a text label and know what attributes we can add on and do it programmatically. But I think if I didn't have to just pick one, I'd say it should probably be a mixture and get the best of both worlds. And then hopefully down in the future, once Swift UI matures, um, hopefully that's where we go to fully, right, down the road eventually. So no problem. I'm glad someone got something out of that. I'm always worried that like I'm talking to like the best of the best, or like they've done everything not sorry that like they've done everything that I've done and more, right? And there's always, when you look at developers, everyone has their different strengths and weaknesses. And I think for me, starting off programmatically, that definitely ended up being a strength for me. So I always think that everything I know, these people already know in front of me. So I'm already kind of nervous chatting with y'all. But I'm glad that worked out for you. Yeah, true. And that's one thing you learn as a developer, that as you learn more about iOS or whatever it may be that you're chasing after, the more you learn there is to know. And there's this ever-reaching ceiling that you're trying to get. You never get there. Yeah. So right. So that's the dictionary that you pass in. So you can define whatever you want. It could be padding if you want. So you're passing a key value pair, where your key is whatever you want the metric to be called, and your value is whatever the float is that you're passing in. And that's why I say you can add that in globally somewhere. That way, if you do need to change it down the road on the fly, it's in one spot and then works everywhere. Yeah. Anyone else? Yeah. What is it? Right. In a group, there's an actual like thing called group. Play with this. What are you testing? What was the Swift UI? Oh, so that's what they. That's interesting. Oh, you can't have more than 10 in a group still. Okay, cool. Same thing, yeah. Not that we would ever want to do this, but wait, no, sorry, this is still one too many. We're good. Cool. Cool. See, I learned something new too. Anyone else have anything? Yes. Here. Ooh, maybe you can do like if you call up the library and say group. Nope, that didn't do it. Say it again. Command right click or just command click? I'm trying. Oh wait, maybe this is it. Done something. Oh, there it is. It's a Command Option Shift. It's a really weird way of holding my hand. Embed in HStack. Nice. Cool. So this was that was outside. That was part of the group before. Right. Cool. That is a useful tip. Yeah. So what he was showing is if I remove these from there, I can go select them all, and I can do this weird thing with my hands. So I do Command Shift Option, right click. Nope. Oh, what did I do? I don't know what I. Oh, I went. Maybe I did one too many. This. No, that wasn't it. So this lets you do it one at a time. Go to options. Well, I'm gonna play around with this more and figure out what I did. But we're close. Yeah. Cool. That's a cool tip. Anyone else have anything? Victor in the back. Sorry.
So how do you avoid when you write your view controller programmatically? How do you avoid having a massive view controller?
How do you avoid a massive view controller? That's when you're doing it programmatically. So I guess the best way is to use extensions to help. I use it to break up my view controller when I'm doing things programmatically, splitting that across different files, I guess. But at the end of the day, that's still going to leave you with a large view controller, right? Yeah, if that is your end goal, to have a small view controller, then maybe programmatic isn't always for you, because I mean it will be large, depending on what you're trying to do, especially with something extremely advanced. But I feel like you're getting way more out of it doing it programmatically that way than the issue of having too large of a view controller. Is there any tips that you know off the top of your head?
I would say just composition. So you compose your views with like smaller reusable view controllers.
Sure, yeah, but that's definitely another way. So if it's something that you can reuse, especially constraints, I would add that. Like let's say setting it to the bounds or views that you reuse all the time, you can set those constraints in one spot, and like a constraints file, and then just call that method whenever you need to set the view controller. So that I guess would help lower your view controller size. But yeah, if we're just talking about like one custom view, then it might be a little larger. But yeah, definitely when you do reusable, you can always mix and match, and however you can minimize code in a view, you can do it with programmatic constraints as well. Yeah.
Thank you.
Yep. Good question. You're saying setting programmatic styles for storyboard IB outlets. Not a pre-experience proxy, but you have I'm trying to think what the name off my head is, IB. You stick in the storyboards. Inspectables, thank you. That you can add to the storyboard.
Jessica, could you repeat the question?
One. It was.
Sorry. It should say mic right near your thumb. Or you can take this mic.
Okay. Yeah, so my question was like, I think originally when we started this topic where, we have differences between doing things in storyboards and then doing it programmatically. And one of the advantages was like, oh, okay, if you do it programmatically, we have one central place where we can kind of change styles and stuff, right? Like, so if you actually created a UI button, for example, programmatically, and you have that custom button, and you can change it and it'll change it everywhere. So if you're using something similar where I don't want to touch the storyboard,
Right.
but I still want to have that ability to change the style, like how would you kind of go up around doing that? And what I was suggesting was there is a UI proxy appearance,
Right.
which enables you to do exactly the same thing by leveraging storyboard, but you can programmatically change styles.
Right. Yeah. So that's me. I have not messed with this much. I have used the IB inspectable at one point, but yeah, lately I did not get a chance to do that. So I mean, for just manipulating views like that from storyboards, I just end up doing with an IB outlet, and then
yeah. So the primary purpose, purpose why you will use UI appearance proxy will be to theme your app. So you can leverage storyboards as it is. It's just you will add a UI appearance proxy, and then you will tell it whenever it's contained in this, your controller, change that color for this UI button.
Right.
And you can do a lot programmatically.
Yeah. Now go ahead.
Yeah.
With the new asset catalog. Yeah. So yeah, that's a nice new way to go ahead and set all your colors in one spot. But I mean, you're still gonna fall on the issue of like fonts and font sizes that way. Yeah. So I'll start a new one because I'm using a UI here.
Just as a quick time check, we can make this the last question, and then what I just want to make sure that people have time to kind of socialize and kind of chat. And I have a couple last minute updates, but we'll have plenty of time to kind of spread out.
So just doing you want to do an IB action is what you're asking. So I am creating a new project with Storyboard. All right, so in my view controller, I can go to my main storyboard. And on here, we'll add a button. Where do they keep those now? Up here? Yeah. So an IB action would just be going to this view controller here. Oh, this is going to be tough to see. We'll do it right above this function. So you just, programmatically. Yes, you can do that too. Sorry, I misunderstood the question. Yeah, I was like, okay, we can do that too. So I can create a lazy var. All right, so button down perform selector. Been a while. The target. Ah, that's right. Okay. There it is. All right. So the targets usually are self, right? And then our action would be the selector that we have. So we can create a function down here. That's yep. Oh, sorry, you're right. My bad. Yeah, for selector, of course. Okay. And your action will be selector. Adding this action to it. For event touch up side. So that's when the user lifts his finger, because otherwise, sometimes they don't meet the touch, and they'll pull their finger off the button to touch up inside. And then down here, it's just complaining that we don't do that. Here we can, the action can be a print statement of some sort that does something. That's it. Yep, super easy. Yeah, it's a little tough when you're on the spot. Huh? Yeah, that's right. Cool. All right, well, thank you guys so much for coming.